starting with the reciprocal function, 1 over f of x there's the table of values. What I'm going to look for first is that undefined value, because when we're looking for the reciprocal function, we're looking for the 0, which gives us the vertical asymptote. So go the other way around, we want to find that undefined value, which gives us a 0 position on the, f of x function. So the rest of it, we can just do reciprocal values and see where they land. So at -5, we're at -1, -4, -1/2, -3, 1/2, and at -1 is 1. We can see that's a linear function that's going through that 0 there. And again, the key is, since the 0 gives us undefined, the reverse is also true. So we're going to find the 0 first. So what's the most important part when considering reciprocal functions? Well, the most important part is when f of x equals 0, because that gives 1 over f of x is our vertical asymptote. Okay, so that's the most important part. The other parts we can consider are the reciprocal relationship. As the y goes towards the x-axis, the reciprocal goes away, and vice versa. The other thing is, and we're not going to, depending on whether we can find them or not, so they will not be as important, but the invariant points when y equals, so I'm going to just maybe list that down, invariant points. Okay, and this is secondary. But this is when y is equal to plus or minus 1, and that's where the original function in the graph will intersect. So when finding reciprocal quadratic functions, we do need to have, again, the vertical asymptotes. That's going to be the keys. Okay, there and there, where my original function is 0. There's the invariant points here and here. Again, if we can find those invariant points, that's great. For example, this case here, although we can find them physically on the graph, it's harder to find them along the x values for that point. But what is another consideration that we have to do for these quadratic ones? What's another consideration is the vertex. Okay, so the vertex. We want to be able to locate that vertex. So the vertex here is at 0 and 3. So then the reciprocal, will have a coordinate at 0 and 1/3, and that point then represents a point of interest. Okay, so this is a vertex on the reciprocal function, and then we can draw in the rest of that and follow the asymptotes, go through the invariant points, and draw that in. Lastly, the domain and range. For the domain and range of these rational reciprocal functions and absolute value functions, the domain and range is going to be determined by the restrictions. So here I have a restriction in the denominator that x cannot equal to 7 over 2 or 3.5. Okay, so 7 over 2 represents a restriction on the x. They also, for my domain, it's going to be all real numbers except for x is not equal to 7 over 2. For the range, we have to think of where the horizontal asymptote is. So in this case, the horizontal asymptote is going to be at 0, which means then that this graph, since it doesn't cross 0, it means that the y will not be equal to 0 as well, because it's going to follow the asymptote of 0. For the domain and range of absolute value, we have to think of what are the possible inputs and outputs. Well, the input, we can put anything in for x. It's the output that's going to be restricted, and we can think of this in terms of the graph of this function. So if I sketch the graph of this function at x is 5, y is -3, it's a v function facing up. That means that if it's facing up, we know that the domain, first of all, will be all real numbers. The range then was going to be for everything from that vertex point up. So y is going to be greater than or equal to -3, and we can locate the vertex knowing how this graph looks like.